Hello friends, welcome to my channel EduSup. In today's video, I am going to talk about Kepler's laws. Kepler's laws are a set of 3 laws given by the scientist Kepler, hence named Kepler's laws. The 3 laws are as follows. The first law is law of orbits. The second one is law of area. And the third and the last one is law of time period. Now I am going to discuss in detail about each of these laws. Our first law is law of orbits. Before learning about this law, we need to know about two important terms. These two terms are orbit and the shape eclipse. Let's focus on our first term. Orbit is the imaginary path or line along which a planet revolves around a star. This term will be clear from a figure. Let's say this is our star around which the planet is revolving. Then the path along which this planet will be revolving the star will be known as an orbit. Now let's move on to our next term. Our next term is eclipse. Eclipse is an geometrical shape which looks like a stretched circle. It has two foci. It has two axes named minor and major axis. There are many confusing terms in this definition. Let's understand it from an example. Let's suppose we have a wire or clay in shape of a circle like this. What we do is start pressing it from the vertical direction. The shape which we will get will be like this. This shape is known as an eclipse. Let's draw it with a pen. The shape will look somewhat like this. As a circle has a center, this shape, that is eclipse, has two centers of foci. Let's mention them. As a circle has its radii, this shape, that is eclipse, has two radii, or rather two axes. The shorter of the two axes is known as minor axis and the larger one is known as the major axis. After understanding about our two terms, let's move on to our law. Our first law, that is law of orbits, gives us information about the orbit of a planet. It says that the orbit around which a planet revolves a star is shaped like an eclipse, and the star around which the planet is revolving is situated at any one of the foci of the orbit. Let's understand it from a figure. Let's say we have a planet A revolving around a star. Then the orbit around which it will be revolving the star will be shaped like an eclipse. And the star, as shown in the figure, will be situated at any one of the foci. Now let's move on to our second law, that is law of areas. The law of areas states that the area swept by a planet in its orbit in equal time intervals is equal. Let's understand this with a figure. Let's say we have a planet revolving a star in its orbit. Let's suppose at time t0 the planet is situated at point A. After a time interval t, the planet moves to the position B, and after the same time interval, that is t, the planet moves to the position C. Let's join the points OA, OB and OC. Now, according to law of area, the area of the sector OBA is equal to the area of the sector OBC. Now, let's recall our law of area again. Law of area states that the area swept by a planet in equal time intervals is always equal. Here, the planet sweeps the area OAB and OBC in equal time intervals, that is t. As the time intervals are equal, Hence, the area is also equal. Now let's move on to our third law, that is the law of time period. Before knowing about our third law, we need to focus on a special term which is known as semi-major axis. We have learned till yet that an eclipse has two axes. Now, what is a semi-major axis? We know that the major axis is the larger of the two axes of the eclipse. Here, the smaller axis divides the larger axis into two equal parts, and each of the equal parts are known as semi-major axis. Knowing the term semi-major axis, let's move on to our law. Let's suppose we have a planet revolving around a star, and the total time taken for this planet to revolve around this orbit be t. Let the distance of the semi-major axis be r. Let's mention it here. According to law of time period, t square is proportional to r cube. That is, the total time taken for the planet to revolve around the star taken to the power 2 is directly proportional to the semi-major axis taken to the power 3. This can also be stated as t square upon r cube is equal to constant. That is, the value of t square upon r cube is always constant for all planets. With this, we finish all the three laws that were included in Kepler's laws. Thank you.